Okay, in this presentation we are going to use, this is logarithms essentially. So essentially what we're going to do here is solve the equation 10 to the 2x minus 10 to the x plus 1 plus 24 is equal to 0. Essentially what we have to do is solve it for x, okay? So the solution is as follows. So what we're going to do here is just state the numbers there again. Okay, but essentially what I'm going to remark upon here is 10 to the 2x, that can be rewritten as 10 to the x squared. Okay, that's one of the rules of powers. Okay, 10 to the x plus 1 can be written as 10 to the x times 10 to the power of 1. Okay, or in other words, 10 times 10 to the x. Okay, 24 we'll just leave alone in this particular instance. Okay, so that's just sort of just what I've sort of used there. Okay, so again, 10 to the 2x can be written as 10 to the x squared. Okay, 10 to the x plus 1 can be written as 10 times 10 to the x, and 24 we'll just leave alone. Okay, so what we actually have there is a little quadratic. So I'm going to sort of remark that what we have there is in this form, letting 10 to the x equals y. Okay, so this is a very simple sort of quadratic expression, and you should be able to factorize it fairly easily. Okay, so when you do factorize it, you should get y minus 6 and y minus times y minus 4 is equal to 0, or in other words, y is equal to 6 and y is equal to 4. Okay, and then therefore, if y is equal to 6 and y is equal to 4, 10 to the x is equal to 6 and 10 to the x is equal to 4. Okay, so those are the two answers there. Let's just shove that up a bit. Okay, so now we just use logarithms to solve that, and we should be finishing this particular question off quite quickly, and we'll move on to the next one there. So log of 6 to the base 10 is equal to x. Log of 4 to the base 10 is equal to x. So essentially just work those out with your calculator or your tables and so on, and you should find that x is equal to, in the first instance, the first part there, x is either equal to 0.7782, or in the other case, x is equal to 0.6021. Okay, so that's the solution set there. Just tuck that into shot a little bit better. Okay, so that's the solution set. So that is the answer to that question essentially for the first logarithms question. Okay, so what I'm going to do here is set up the next one now. So just it's the second part of this question. Okay, and I'll just bring it into shot here. Okay, so something very similar here. Solve the equation 2 times log of x to the base 10 equals log of 2 to the base 10 plus log of 5x minus 8 to the base 10. Okay, I'm going to be a little bit quicker here, but just to remark, if we have 2 log x, that can be written as log of x squared. Okay, so if we have a power or a multiple of logarithms, we can actually rewrite that as a logarithm of whatever's in x to the power of that number there. Okay, it's one of the rules of logarithms. Okay, we have 2 logarithms here, so essentially what we could do there is multiply them into one single expression. So we have log of 2 to the base 10 plus log of 5x minus 8 to the base 10. So we can multiply out 2 and 5x minus 8 to get 10x minus 16. Okay, so what we have here, I'll actually just put this in brackets just to emphasize that x squared necessarily is equal to 2 times 5x minus 8. Okay, we both have the same sort of, we're both carrying out the same operation, so necessarily they must be equal to each other. So x squared equals 10x minus 16. Okay, rearranging that and setting that up as a quadratic, we have x squared minus 10x plus 16 equal to 0. So it should be fairly straightforward now. Okay, that's a quadratic. Factorize it, x minus 8 times x minus 2 is equal to 0. So x is equal to 8, or x is equal to 2. So our solution is 2 and 8. Okay, so that is the answer to the second part of that. So that's just like worked examples using logarithms.